So Stephen Lothrop, I'm an electrical engineer at PAE Consulting Engineers. I'm based out of Portland, Oregon. Today I can tell you a little bit about our company, a little bit about our building, and where we're hoping to go. So we are an MEP consulting firm. We do technology, lighting, energy modeling as well. One of the projects we're most proud of is we did the engineering on the Portland International Airport, which has recently opened. We also work in healthcare, education, data centers, district planning, all sorts of different things. We started 58 years ago in Portland. We've got offices all up and down the West Coast, on the East Coast. And we pride ourselves in being leaders in sustainable design. That's what we're really passionate about is green buildings, advancing the building industry. As you can see, we've participated in a number of living building projects, net zero projects. And our vision is a world with clean air, energy, and water for all. Our goal is to get that done in one generation, which is a very lofty goal, but we love a challenge at PAE. Now, that's great to say, but we actually want to walk the walk. We want to demonstrate that we're doing something. So we took on this project of creating the PAE Living Building, our headquarters in Portland, Oregon, 58,000 square foot building that we wanted to be net zero water and net zero energy. And even more than that, we wanted it to be developer led. So we participated with our architects, other developers, to make this a building that would have an appreciable ROI to prove that this can exist in the real world and not just as a pilot project, but as a commonplace project. So we decided to pursue the Living Building Challenge certification, which is why we call it the PAE Living Building. It's got 7 petals. We touched on kind of the energy. We've got PV on the roof, water. We are net zero water. We also are a well certified building, meaning we really care about our occupants and employees, comfort and health in the building, and many other things that we don't have time to get into on here. Another challenge is we are in a historical district in Portland, Oregon. We wanted to be a place that was next to transit, next to bike paths, so people had a number of different options to get to work. But that means that we had to contend with architectural review boards, making sure our building fit into this historical district, making sure that we didn't damage Portland landmarks in the process of construction. We also decided, or eventually happened, that we started building this during a global pandemic. So we had a number of different challenges going on, but we really pushed through and made it happen. So here's a picture of it being built. You can see all that cross-laminated timber, glulam beams. And the result is a commercial building designed to last for 500 years, designed to withstand earthquakes, floods, or anything else it could be thrown at, collecting its own rainwater, generating its own electricity. Couple interior shots. We've got all those wood beams. We've got the structural concrete core designed to ride through that big Cascadia earthquake. The venting you see here is just providing fresh air. All our heating and cooling is done through that radiant slab. We've got power automatic windows that open and close to provide natural ventilation. We've also got our decking with fully opening windows, advanced AV systems, a lot of different systems going on in the building. Going back to the water, we collect all our own rainwater and we process it. We do have a connection to the outside water utility, but we do not use it. Same with our sewer. We have a vacuum flush toilet system, and so we're processing all that internally and not sending anything out back to the city. So here's our water system, water processing. And from left to right, we've got water heating. We've got our gray water system. Of course, we're not just throwing away all that water. We're using it to flush our toilets. And then far in the back, we've got our composting toilet system, capturing everything from the toilets and processing it there. Here we've got our radiant slab heating system, a pretty small mechanical room, all things considered for a building of this size. And then on to my favorite thing, we also have a full microgrid in the building. We've got batteries on the ground floor and PV on the roof. These are designed to operate with the grid, lowering our demand charges, capturing that sun energy during the day, releasing it at night, and also designed to operate off the grid should that ever be needed in an islanded mode. So full microgrid there. Which brings us to how do we connect all these things? We have an amazing advanced microgrid, an amazing advanced water system, but they were never designed to talk to each other. And this is the problem that we really saw is if we want to take our building to the next level, it's already a very smart building. You know, every branch circuit is metered. We have tens of thousands of points of data, but what do we do with it all? And so when I went to AHR, I found the Coalition for Smarter Buildings with a potential solution to this, to unlock all these assets, to break down these silos, to get these different systems communicating together in our building and really advance us to that next level.